Hello, everyone. I'm at Arizona State University. I'm with Don Balansat, who is with the Physics Instructional Resource Team, or PERT.
Yes.
And I want to know about light. What exactly is light?
So light is an electromagnetic wave. Electric fields will travel through space, oscillating up and down, and a magnetic field will be 90 degrees out of phase. Yes, there's a great picture of it right here. This is how we define the electromagnetic wave and therefore light.
And so when we're talking about, using solar energy, mainly from the sun, right?
Yeah.
So how does the sun and electromagnetic radiation and light all come together?
Right, so the sun obviously emits visible light. We call it visible light because it's the light that our eyes have evolved to see. It's red, orange, yellow, green, blue, indigo, and violet, right? And yeah, those are the colors of the rainbow, and it's also all types of light that the sun emits. But what a lot of people don't know is that that only makes a small sliver of the electromagnetic spectrum as a whole. So the sun actually also emits ultraviolet and infrared light in large amounts. So if we look over here, you can see that there's a big spectrum of which the visible light that we see is only a small part. Actually, it's only about 1/1000% of the entire spectrum.
And so light is this entire spectrum.
Right.
And
all the way down from radio waves to gamma rays.
And then what our sun emits mostly is in this range here.
Yes. Precisely.
And so when we're thinking about harnessing sunlight for energy, we concentrate on the visible spectrum, which is what we can see.
That is correct. When solar engineers and scientists are trying to develop new ways to harness the energy, they're looking for materials that can better gather the energy that the sun is giving out to us.
Yeah, because this area is the biggest output from our star, the sun.
I believe it's about 46% of its total light is in the visible range.
And the others are just outside of that range, going in this range.
Yes, ultraviolet and infrared.
Okay.
Right.
Yeah, that makes sense. And so when we're talking about the light as the entire spectrum, how does it change? Like, what's the difference between a radio wave or an X-ray?
What differentiates these?
Yes, what differentiates them?
So radio waves are really long wavelengths. They can be meters upon meters. Even the longest ones are kilometers wide. And they have very low energy because they're these really long waves. And as you go up the spectrum, the wavelengths, if you want to show this picture again, the wavelength, the distance between where it goes back and forth becomes smaller and therefore more energetic because it's bouncing up and down, say, a lot more times per second. And gamma rays, it's really, really energetic compared to the radio waves.
Okay, yeah. Wow, that's really great. And so now when we're thinking about solar energy and we're using the power of the sun, we're talking about capturing the visible spectrum and converting that into electricity.
Yes, exactly.
Fantastic, thank you.
No problem.